Welcome back. Today we're going to look at the second part of 6.3. Our learning target again is to add and subtract radical expressions. We're also going to look at foiling out radical expressions and then adding and subtracting like terms. So here's some more practice on foiling those binomial radical expressions from yesterday. Remember that if it says we are squaring something, it means we have two of them that are getting multiplied together. So we can just write these out as two identical factors. So think of this as 2 plus the square root of 3 times 2 plus the square root of 3. All right, remember we're doing that foiling process where we take 2 and multiply it to the 2 and get 4. We take 2 times the root 3. Now remember, the 2 is outside of a root and the 3 is inside. So all we can do is show that those are being multiplied together. We can't actually combine them into a 6. Insides, we end up with the same thing. We have a 2 times a root 3. And our last term, we end up with a root 3 times a root 3, which becomes the square root of 9, which is just a 3. And now when we combine like terms, we have a 4 here. We're adding 3 more. That's 7. And for our root pieces, they are both root 3s, so we can combine them. We have 2, and we're adding 2 more. So we have 4 of those root 3s. Okay? For our next one, let's think of this as 3 minus root 10 times 3 minus root 10, two identical factors. The 3 times 3 would be 9. Outside, we're going to get 3 times a negative root 10. So we have negative 3 root 10. And insides, we get exactly the same thing. So another negative 3 root 10. Anytime you have two identical factors, your insides and outsides are going to match. Our last term, we have a negative times a negative, so it's going to come out positive. We have a root 10 times a root 10. We get root 100, which is 10. Combining like terms, we can put the 9 and the 10 together to be 19. And we can combine our radical pieces since they're both root 10s. We have negative 3 and we're subtracting 3 more, so we're subtracting 6 root 10s. So 19 minus 6 root 10 would be your solution. Now notice that these are slightly different. These have opposite signs. One is a positive, one is a negative. There is a special name for that. We call these difference of squares. And you'll see why when we look at our answer. So we're basically taking a sum and a difference, and we're multiplying those together. 4 times 4 would be 16. Outsides, we get 4 times negative root 7, so negative 4 root 7. But insides, we have a positive 4 times root 7. Last term, we have positive times negative, so negative. A root 7 times a root 7 would be a square root of 49, which is just a 7. So now when we go to combine terms, we have the 16 minus the 7, so we have 9. And our insides and outsides drop out because we have a negative 4 root 7 and we're adding a positive 4 root 7. So when we have a sum and difference where one is a plus sign and one is a minus, everything else is the same, we end up with just a nice integer value. And that's going to be important as we move on to our next page of notes. Let's go ahead and try this one. First term, 2 times 2 would be 4. Outsides, 2 times negative root 6 is negative 2 root 6. Insides, we have 2 times a root 6, so positive 2 root 6. And last term, root 6 times negative root 6 would be negative square root of 36, which is just a 6. So we have 4 minus the 6, we get negative 2, and our middle terms are going to be opposites, so they drop out. Okay? So we've seen things like 4 divided by 2 minus 3i back in chapter 4. And when we looked at how to rationalize this or simplify it, we ended up multiplying by the conjugate of the denominator. We had a 2 plus 3i that we had to multiply in. Well, the same kind of thing is going to happen today. We have to rationalize this denominator. We can't leave square roots in the denominator. So the first step, we're going to find the conjugate of the denominator. So if we have a 2 minus root 3, we're going to multiply by a 2 plus root 3. But we have to multiply that to both the top and the bottom, the numerator and the denominator. For the top, we can just distribute. 4 times 2 would be 8, and 4 times root 3 is just 4 times root 3. But on the denominator, we can actually FOIL that. And what we should get is a nice integer value, because this is just like the questions we did on the previous page. We had one negative and one positive. Those inside-outside parts of FOILing should drop out. We should have no square root in the bottom part of this fraction. Okay? So, FOILing it out. 2 times 2 would be 4. Outsides, we've got 2 times root 3. Insides, we have 2 times negative root 3, or negative 1 root 3 times 2, negative 2 root 3s. And a negative root 3 times a positive root 3 becomes negative root 9, but root 9 is just a plain 3. So our solution here, our simplified answer, we have 8 plus 4 root 3 for the numerator. In the denominator, our insides and outsides dropped out since they were opposites. And we have 4 minus 3, which is just a 1. Now, do we have to put the 1 under there? No. We could just simplify this down to 8 plus 4 root 3. It's okay to have a denominator. It's just not okay to have a square root in the denominator. All right, let's look at this next one here. We have 4 divided by 5 plus root 2. So we're going to multiply by its conjugate, 5 minus root 2. Distributing on the top, 4 times 5 would be 20. 4 times a negative root 2 is negative 4 root 2. For the denominator, 5 times 5 is 25. Outsides and insides are going to be opposites. One is a negative 5 root 2 and one is a positive 5 root 2. So those are going to drop out. And our last term, we have a positive times a negative, so it's negative. Root 2 times root 2 is root 4, which is just a 2. All right, cleaning this up. We have 20 minus 4 root 2 for our numerator. For the denominator, we have 25 minus 2, since the insides and outsides drop out. 25 minus the 2 would be 23. All right, this one is turned around slightly. The square root is in front here, but it doesn't matter. We have a square root in the denominator, so we have to use its conjugate. The conjugate is going to look exactly the same except for that middle sign. So for this one, we have to multiply by a root 7 minus 2. For the numerator, when we distribute, we've got negative root 7 and a positive 2. For the denominator, we have a root 7 times a root 7, which is root 49. We have negative 2 root 7 for outsides. Insides, we have positive 2 root 7, so those are going to drop out. And our last term, we have a 2 times a negative 2, which would be negative 4. Simplifying, the square root of 49 is just a 7. So our denominator, once we get rid of our opposite terms here, we have 7 minus 4. Our denominator is going to be 3. So negative root 7 plus 2 all over a 3. All right, let me know if you have questions. Your homework assignment today will be worksheet 6.3b.